0 to pi by 2 r square. R is 2a upon 1 plus cos theta. This will be 4a square upon 1 plus cos theta whole square. I'm sorry, this was the question here. Alright, so that's the point. Now let us solve it. So this is 1 upon 2a square. Let me take outside. 0 to pi by 2. In the denominator we are having, let me take 2 cos square theta by 2 inside, and that will be 4 cos 4 theta by 2. It will give us, why? Because this is 2 cos theta by 2, 2 cos square theta by 2. Whole square, that will be 2 cos 4 power theta by 2. Let me further solve it. This is 2 upon 2, that means a square upon 2 here. This is 2 to the 4. 0 to pi by 2. And this is second 4 1 upon 2 theta into d theta. Okay, we can convert that into sec square theta by 2 into 1 plus tan square theta by 2. If I substitute that, a square upon 2, this is second square 1 upon 2 theta by 2, theta, into 1 sec square theta by 2 is 1 plus tan square theta by 2 into d theta. So if I put tan theta by 2 is equal to t, if I substitute, for this whole value is equal to, no, tan theta by 2 we have to substitute something. Then it will be sec square theta by 2 equal to d theta, or into d theta equal to, this limit is 0 to pi by 2. Okay, so what is that formula here? Let me find out that value. What is the, this is the last value of this parabola, but this will give us, let me solve it here. So it is giving us a square upon 2, limits 0 to pi by 2. It is 1 plus tan square theta by 2. Because sec square, 1 sec square theta is converted into 1 plus tan theta by 2 into second square theta by 2 into d theta. Now if I putting tan theta by 2 is equal to t, let me take, it will give us sec square theta by 2 into 1 upon 2 into d theta is equal to dt. Differentiating with respect to t here, differentiating it with respect to t, we get this sec square tan theta by 2 is sec square theta by 2 differentiation, and 1.2 because theta by 2 is again differentiated by function over function method, so this is 1.2. This means second square theta by 2 into d theta equal to twice dt. Okay, and what are the limits here? Limits. So this is tan theta by 2 here. Try to understand. At pi by 2, if I put here theta pi by 2, it will be pi by 4. T will be 1. So at theta is equal to pi by 2, t is equal to 1, because tan pi by 4 is 1. Here it is theta by 2. In place of theta we put pi by 2. So pi by 2 into 1.2, that means pi by 4. Tan pi by 4 is 1, so t is equal to 1. And at 0 it is 0. Tan 0 is 0. So t at theta equal to 0, t equal to 0. So limits are 0 to 1. Try to understand. Okay, so what is the point? This is 2 dt. So here we obtain this as a square upon 2, limits 0 to 1. Now it is 1 plus t square into 2 dt, because sec square theta by 2 d theta equal to 2 into dt, this is 2 dt. Okay, so and limits 0 to 1. Now let me integrate that. A square upon 2, this 2 cancel out, I'm sorry. This is only a square only. And integration is t plus tq upon 3, t plus tq upon 3, limit 0 to 1. It is nothing but a square into 1 plus 1 upon 3, that means 4 by 3. 4 by 3 a square. This is the parabolic area under the parabola OABO. This is the area. I'm sorry. Initially I calculated as A square, A only. I'm sorry, that is not answer. So this area, which was of cardioid, this portion from pi by 2 to pi, this was the fourth one, this is the fifth one. Let me now find out total shaded area, common area, and this is 4 by 3 A square. This is the fifth one, this is the fourth one. These two are added up, this plus this, then twice of that, the total common area. Therefore, total common area is equal to sum of these two, adding twice of fourth plus fifth. This fourth one, this one plus fifth one. So this area OBCO, OBCO, and this is area OABO. This is area OABO. This area, and this is OBCO, this area. Sum of these two, adding fourth and fifth, twice. This area is, first let me take 4 by 3 A square, fifth one, no problem, plus 3 pi A square upon 2 minus 4 A square, 3 pi A square upon this. Okay. Now multiplying this by 2, or we could first solve inside and then multiplying by 2. That can also be done. This is minus 4 A square. Okay, and this is 4A square upon 3. 3 4 is 12. It will be negative sign. So twice. Let me take first 3 pi A square upon 2 with minus sign. 3 4 is 12. 12 minus 4 means minus 8 A square upon 3. 3 taking LCM. So 4A square in the numerator minus 3 4 is 12A square. 12A square minus plus 4A square minus 12A square plus 4A square is minus 8A square upon 3. So this is the area, which is shaded area, total area. These two portions, twice of this is the total area. Now if I find out this unshaded area, that means this 6 pi square minus this. Let me now multiply by 2 inside. So this will be 3 pi A square minus this is 16 A square upon 3. 2 into 8, 16 A square upon 3. Okay. So this is the shaded area. Okay, this is the shaded area, common area. Now unshaded area, non-common area, which is this one, we have to find out by 6 pi A square, which is the area of the whole cardioid, minus the shaded portion. That will give us, okay, non-shaded area. So let me find out non-shaded area or uncommon area. Now non-shaded portion of the cardioid is equal to 6 pi A square. This is area of the whole cardioid minus shaded portion, and shaded portion is 3 pi A square minus sign 16 A square upon 3. It is nothing but 3 pi A square, because 6 pi A square minus 3 pi A square, and this is plus sign 16 A square upon 3. This is 9 pi A square plus 16 A square divided by 3. This is the non-shaded portion, and this is the shaded portion. Shaded portion is 9 pi A square, or it can be written as 9 pi A square minus 16 A square upon 3. This is shaded portion. Okay, so this is non-shaded portion, non-shaded, which we have written above. So we have to find out these two, ratio of these two. So let me find the final answer. Ratio of the two common areas. Either first write shaded and then non-shaded. Let me first write shaded portion or then non-shaded portion. So ratio, therefore, ratio of the two intersecting areas, we may say two areas. Let me take two areas. Here is common area or shaded portion divided by non-common or non-shaded portion, non-shaded area. So first common area is this much, which is 9 pi a square minus 16 a square. A square can be taken common. Upon 3 it was. This is upon 3 divided by 9 pi a square plus 16 a square upon 3. Now this 3 cancel out. Okay, only a square can be taken out. So a square is taken out. 9 pi minus 16 divided by a square taken common. It's 9 pi plus 16. A square cancel out. So the ratio is 9 pi minus 16 is to 9 pi plus 16. This is the answer. Okay, so ratio of the shaded portion and non-shaded portion, or shaded portion non-shaded portion can be taken in the numerator and non-shaded portion in the denominator. This is the ratio. Question number 3 is lengthier one because of that it has taken more time. No problem. Now let us take the fourth question. Question number 4 now. Question number 4. What does that say? Let me check that. So question number 4 now, or fourth question. What does fourth question say? What does question number 4 say, or question 4 say? Okay. Now fourth question, let us discuss about. Okay, so question 4 says, find the area outside the circle r equal to 2a cos theta and inside the cardioid r equal to a into 1 minus cos theta. No problem. Let us talk about that. So again, intersecting point of these two, we have to find out. Question number 4 here. Again, common area inside the circle and outside the, that means common between them. Okay, r equal to, fifth one. So find the area outside the circle and inside the, so circle is inside the cardioid. That is the point here. Okay, so let us talk about that. First intersecting point of these two. So what is the circle and circle. So the two curves, the two intersecting curves, the two intersecting curves are circle. First is circle. First circle is r is equal to 2a. R is equal to 2a cos theta. Yes, r equal to 2a cos theta, and inside is the cardioid, and cardioid is r is equal to a into 1 minus cos theta. A into, this is of different kind, 1 minus cos theta. This is second equation. This is the first equation. Let me first find out what is the intersecting point of these two. Solution. So we have to find out the solution and then the common area between them. So what is the circle here? Let me just calculate. We are solving them. So solving first and second, we get, putting value of r, so this is twice a cos theta is equal to a into 1 minus cos theta. A cancelled out. Yep. So this is 2a cos theta is equal to 1 minus cos theta. Now 3 cos theta minus 1 equal to 0. Okay, because this is 2 into, is there anything mistaken? R equal to 2a cos theta, R equal to 2a cos theta, and R equal to a into 1 minus cos theta. So a cancel out, twice cos theta. Okay, so that is there. Twice a cos theta equal to a into a cancel out. So 2 cos theta equal to 1 minus cos theta, 3 cos theta equal to this. So 1.3 it comes out to be. So theta equal to, but this is 1.3 here. Cos theta equal to 1.3. So cos theta is equal to 1.3. So 3 cos theta equal to 1 upon equal to 1 in this case. So but angle is not coming. So theta equal to cos inverse of this. Theta equal to cos inverse 1.3. Is it okay? But what the question? Find the area outside the circle, and this is outside the circle. So circle is not. I'm sorry. Circle is not coming in picture. There is no common point here, and inside the. So what we have to find out? Find the area of these two, and subtract them. Simple question. So no common area. Okay, so what is the area of the whole circle? Inside the circle and outside the cardioid. Simple, no intersecting point here. So this we have not to find out the intersecting point. Only what we have to do, we have to find out the two areas and subtract one from the other. Simple. So let me draw those cardioid and circle. Okay, so cardioid and circle if I draw, then area of the two, then subtracting them, that will give us the area. So first of all, or this may be taken as initial line, y-axis, y-dash axis, no problem, this is initial line here. Okay, so first is cardioid. In this case, this is a into 1 minus cos theta. That is going to give us, okay, so that is going to give us the same kind of question is here. Okay, so that is a point I was just calculating. I'm just replacing the duster here. Sorry, friend. Okay, so the circle is okay, and this is the circle. If I take this, inside the circle and outside the cardioid, the common area or outside the circle area is this much. So simple, we have to find the two areas and subtract area of circle from the area of the cardioid. Simple, nothing else. And the limits are 0 to pi, or it could be drawn like this. It is 0 to pi here, theta equal to pi, and here theta equal to 0. Or this could be done like this. Circle is done inside, but this is the cardioid here. Okay, so area outside the circle, that means circle's area is to be subtracted from area of the cardioid. Area of the cardioid, let me find out. Area of the cardioid is just a shape of the curve. We have nothing to do with this. Okay, so area of the cardioid is, now limits in case of cardioid we always take 0 to pi. 0 to pi here and twice of that. Area of the cardioid equal to twice area. We take this is O, A, and this is B here. Okay, O, A, B, O, B, O, A, B, O. Okay, twice of O, A, B, O. No problem. This is the point which is intersecting the line at theta equal to here pi by 2, but pi by 2 limit we are not to take. Just limit 0 to pi. Total area of the cardioid we have to find out. Simple. This is twice. Calculate total area. 1.2 we put here. Limits here 0 to pi. This is r square into d theta. 2 to cancel out. This is 0 to pi. R square is in this case from the cardioid. This is this much. This is a into a square into 1 minus cos theta whole square into d theta. This will give us, okay, let me open this. This is a square. Let me take outside 0 to pi here. Opening this is 1 minus 2 cos theta plus cos square theta into d theta. Again, this is a square 0 to pi 1 minus 2 cos theta. Here it is 1 plus cos 2 theta upon 2 cos square theta is, this is d theta. Since, let me write here now, 2 cos square theta is equal to 2 cos square theta equal to 1 plus cos 2 theta, or cos 2 theta equal to 2 cos square theta minus 1. Therefore, cos square theta equal to 1 plus cos 2 theta upon 2. This cos square theta is. Now, further solving it, it will give us, so further solving it, it will give us a square into 0 to pi. Alright. And this is now 1 plus 1.2, 3 by 2 again, minus 2 cos theta. Plus this is 1.2 cos 2 theta into d theta. So let me integrate this. Integrating this is a square 3 by 2 theta minus 2 sin theta. Cos theta is integration sin theta, and plus sin 2 theta upon 4. This we are doing a number of times. This is 0 to pi here. Only at pi the value will be there. At 0 everything will be 0. This is nothing but a square into 3 by 2 into pi only, because sin pi 0, sin 2 pi 0. At 0 every term will be 0. This is the only value. This is nothing but pi, 3 pi a square upon 2. This is the first total value of the cardioid. This is the area of the cardioid here. This, let me take first equation. Area of the cardioid is equal to 3 pi a square upon 2. Let me take this is third equation. Okay, this is the third equation here. Area of the cardioid. Now let me take what is the area of the circle here, and then subtracting area of the circle from area of the cardioid. Simple answer. That is the question required here. Okay, now area of the circle. Now area of the circle. Again, so this is this area. Okay, 0 to pi here also limit people substitute and twice of that. Here also 0 to pi total area. Okay, so area of the circle is this one 2a cos square theta. So total area of the circle we have to find out. Total area of the circle is equal to twice area OA. Let me take here C. This is the point C. So OACO, twice of that. Twice into 1.2. This is r square, limits 0 to pi. Or 0 to pi. So into d theta. Go to cancel out here. 0 to pi here. R square is 4a square into cos square theta into d theta. Okay, is it pi by 2 or pi here limit? Let me think about. Now here limits are In case of circle, area of the circle is 0 to pi only. Okay, 0 to pi we have to find out. Area of the circle is, or we can find out just directly what is area of circle here. Radius is 8, where theta r is equal to 2a. So total r is equal to 2a. So radius is a here. So area is pi a square only. Or let me just solve it. But area of this is pi a square, simple. Area of the circle is pi a square. We know that pi into radius is a here. Total is r is, capital R is twice a. Total is twice a from this point to this point. And radius is a. So area of the circle is pi a square, simple. We can just find out like this. So pi a square minus this minus pi a square. Total area we can calculate. Okay, now let me solve this. Let me check that what is coming out from here. Okay, so this is 4a square. Okay, 0 to pi here. But we cannot, okay, we can make it twice, and pi by 2 can be divided. Okay, it is half of this area and twice of this. Limits are 2. That can also be done. Let me take this as 4a square into 2 into 0 to pi by 2. And this is cos square theta d theta. Simple. Now, have we done that twice? That is square we did, it is twice a square, 4a square into 0 to pi by 2 limits is 0 to pi by 2 is the limit here, because 0 to here it is pi by 2. Here theta is pi by 2 at this point. So limits are 0 to pi by 2, in case of this. 0 to pi by 2 here. In case of circle, 0 to pi by 2. Because at this point, angle is theta pi by 2. The tangent line is making angle pi by 2. Okay, so sorry. This is pi by 2 angle here. No need of making twice of this. This is 4a square into cos square theta into d theta. 4a square we have taken outside, twice of this whole area. This is giving us 4a square. I'm just checking that whether pi square is coming or not coming. Or radius is a, we know that pi square is the area of circle. But if we have to calculate, then limits are 0 to pi by 2, or from 0 to here pi by 2. So this is the tangent here. Tangent makes angle pi by 2. Okay. Or we can take here theta 0, and from this point to this point it is 90 degree. Total 90 degree, because y-axis is making 90 degree angle. So 0 to pi by 2 are the limits, sorry. And then under the limit 0 to pi, reduction formula we have to apply. This is 1.2 into pi by 2. This is nothing. 2 cancel out 4 is pi a square. So area of the circle is pi a square. If I subtract this area of the circle from this 3 pi a square upon 2, that area will be the difference of these two. Therefore, let me find out area of the common area. So area between the two, area outside the circle and inside the cardioid. So area outside the circle and inside the cardioid. Inside the cardioid is equal to area of the cardioid minus area of the circle. So this is area of the cardioid minus area of the circle So this gives us cardioid area is 3 pi a square upon 2 minus pi a square area of the circle. So this will give us 2 4 is 3. Sorry, 2 pi a square. So this is only pi a square upon 2. If I take 2 LCM, is 3 pi a square minus 2 pi a square. That means pi a square upon 2. This is the answer here. Okay, so area is this pi a square upon 2. So half of the circle, area of the circle is the answer, common area, or I mean area between the cardioid and circle. That is said like this. Pi a square upon 2 only is the area answer. The answer is pi a square upon 2. Difference of these two areas. Okay. This is question number 4. We have done. Question 4th done. Fourth question is complete. Now let me talk about question number 5. Now question number 5, what does it say? Okay, so question number 5 is now show that the area contained between the circle r equal to a and the curve r equal to a cos 5 theta is equal to this. Between the circle, it says contained between the circle and the curve this. Alright. So area of the curve, this is now, okay, it is having loops here, 5 loops will be there. So those 5 loops we have to find out. R equal to 5 theta, angle will be of what? With that limit we have to find out area of one of the loops, and total 5 loops area we have to calculate, and then circle's area. R equal to A is the radius, and that is the circle here. Let me just calculate that. So here, question number 5 we will draw. Let me take question number 5 here. Question 5, this circle is R equal to A. And what is the second? R is equal to A cos 5 theta. It is. So this is nothing but having the loops, multiple loops. How many loops are there? Odd number is there. R equal to A cos n theta, then n loops were there. In this case, there will be 5 loops, and each loop will be at what? On the tangent line of the loops here. This will be symmetric to the, because cos theta, if I replace by minus theta, doesn't change, so it is symmetric to the this initial line. This is x. Let me take. Circle is now this, having a radius a. Okay, radius is this a. Now it says that there are here 5, because odd number is this. What the first we have to find out how many these loops are there. Solving the solution we are finding out. So number of loops of